Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this minimum steps problem of GFG. So let's move on to the problem, guys. So guys, here we are given a very long problem statement. So I am just telling you what we have to do. So we are given a current position of a ship. So what is basically a problem is we have some ship which are running toward east, means this is the array and they all are running toward east. East is this direction. Okay, it's in this direction. Okay, we have an ship and we are given current position of all IS ship and velocity of all IS ship. Okay, guys, velocity of all n ships as well. Now we are given an integer t. Okay, 3. Yes, we are given t means time. Okay, some time and a b. Now what is b? B is the final position where we want all our ships. Now we have to find out if a ship is starting at current position x with velocity v, then can it reach b within time t. Like suppose if c is equal to 2, velocity is equal to 4 and b is equal to suppose 11 and time given is 5. Time given is suppose 2. Time given is 2. Now if it will start from 2, then after 2 second, what, how many distance it will cover? Time into velocity, that is 2 into 4. Okay, 2 is its starting position and in 2 time it will cover 2 into 4 distance because 4 is its speed. So 4 into 2 is equal to 10. So it can reach till 10. So we can say our b is equal to 11. So we can say this current ship x with the starting point 2 and velocity 4 in time 2 cannot reach 11. Okay, or suppose if time is equal to 3 or any big number, then it will be 3. Then 4 into 3 12. 12 plus 4 is equal to 12 plus 2 is equal to 14. 14 is greater than 11. So we can say if time is greater than is equal to 3, then our ship x will reach b, means at b, definitely, because once if it reach 11 it will stop, it will not go till 14. Okay guys, but in mathematical we have to find out the maximum distance. Now but here one more condition: there is ship x, there is ship y. Now if ship x running with speed 11, suppose 10, and this ship y running with speed 1, and like suppose this node x, this is a very weird problem. Okay, I think this is at 9, suppose this is at 15, or suppose 10. Now after 1 second, after 1 unit of time, this is velocity, this is current. Now after 1 unit of time, what should be the scenario? The scenario should be look like that: it 9 became 19 because in 1 unit it will cover 10 unit. Speed remains same because this is a constant velocity. Now 10 became 11 because it is running with 1 speed. Speed became 1. But this will not be the same. Okay, this will not be the same. But what is the same? After 1 second, this 9 will just reach 10 with speed 1. Why 1? I will tell you. This uh, sorry, this will become 11. 11 1 means after 1 second it will go to 11. This 10 will reach to 11. Now when 9 is going to 10, 9 is going forward, then it will see there is one more ship in front of me. So it will follow its speed. Now it will follow its speed. If its speed is 100, then its speed will also become 100. Okay guys, 100. Okay guys, so this is, but if its speed is 100, then 9 will never be able to follow 10. Okay, so there is one condition: if 9 can only chase 10 if 10 speed is less than 9. Less than 9, yes. Why? Because suppose 9 is here, 10 is here. If I am saying one, after 1 unit it will become here. After 1 unit it will cover y distance, it will cover some y, some x distance, and x is less than y. Okay, then this starting point is already less than its starting point, and speed is also less than, x is also less than y, this is speed. Then 9, this ship will never be able to chase this particular ship. Okay guys, this ship, just a minute, this is a very mathematical problem. Okay, this ship can only follow or chase this ship if the speed of this particular ship is greater than this ship. Okay, because if its speed is greater, then it will always be move forward than this speed, so it can never be match his speed. Okay guys, so this can never be 100. Okay, just a minute. Okay, this is one. So 11 speed became 1. Now it will come to 12. It will come to 12. After one more second, it will become 13. It will become 13. Now speed will become same. Now it will become 14. It will become 14. Speed remains same. Okay, it's 10 speed reduced to 1. Okay guys, so you can see speed decrease. So what we have to do, we have to find out the or guys, here one condition is given. Then if this ship is giving me wrong answer, means this ship is the biggest failure for in the path of this 9 position ship to reach at the end. Then what we can do, we have a crane, or we can put out this ship and put it in before this. Okay, before this means we can ignore this ship and just shift this ship. There you can go, you don't need to follow this, you can swap it, you can swap this particular ship. Okay guys, so what basically question is means, if this ship can reach at the end, this ship cannot reach at the end particular time, then what we can do, so that 9 don't need to follow this 10, we can ignore this ship, so that 9 will reach at the end at the barn position B easily. Okay, so we have to find out total number of these, count total number of these ships that we need to ignore. Suppose here is speed 1 at position 10, as per as position 5, at position 4 with speed 6, position 3 with speed 1, at position 2 with speed 10, sorry, with speed 6, position 1 with speed 6. Okay guys, so here we can see we have to reach, this is position, this is speed, so we have to reach at B is equal to suppose 10. 10 B, this is B, and what is time, time given is 2. In 2 seconds I have to reach 10. Can 5 will be reach to 10 in just 2 seconds? 5 plus 2 into 1, yeah, after 2 seconds, after 2 seconds it will, these all will reach to 5 plus 2, that is 7. It can maximum reach to 7. 4 can reach to 4 plus 6 into 2, that is 16. It can reach up till 16. It can is 3 plus 2 5, 12 plus 2 14, 12 plus 1 13. So we can see only these three ships can be followed. But suppose if this ship have to follow this ship, because we know this ship can never be able to reach at barn position 10, barn position 10, then we can say this ship can never be follow, because this have to follow this never be follow, this have to follow this never be follow, because there is a ship in front of all ship which never be able to reach B in time 2 with current speed 1, and everybody have to follow this one. So this also not possible. Okay guys, but here is a condition, here is one way. If we ignore this, ignore means we are swapping this. Okay, question is written minimum swap, but this is just like minimum number of ignore, that we have to ignore ships, we ignore this. Okay, now for 4 and 6 our path is clearly, but we need to ignore one ships. But 2 and 6 we have to ignore 1 and 1 2 ships. For 1 and 6 we need to ignore 1 and 1 2 ships. So total number of ships we need to ignore 1 plus 2 3, 3 plus 2 5. So total number of ignore we have to do is 5. Okay, so after doing 5 number ignore, the maximum number of ships that I can reach is 2 in time 2 at position barn position B is k is equal to 3. K is equal to 3. K means the number of ships I can easily go to 10 is equal to 3 in time 2 with current velocity and position, all of that is 3. Okay, with me cost is equal to 5 means minimum swap is equal to 5. So if our k is less than 3, what is k? Now k is the number of ships that we need to at one position B. Suppose if we have a ship at with position 1, so it can never be able to, and k is equal to 3. Suppose k is equal to 3 and we are saying our velocity of this is 1, then the maximum distance will become 3. Maximum distance 1 into 2, after 2 seconds 2 plus 1 3, yes 3. So 3 is less than 10, so this ship can never be able to reach out this B. So we can say we have only two ships, this and this, to reach. So we have only two ships, but we require three ships. So what we will do, we will return -1, means we can ignore any number of ships we want, but we are never be able to reach at least reach k ships at the end position. Okay, guys. So and suppose here is 6, here is suppose it is 6, here is one more at 1 with speed 7, then it is after 2 seconds is 7 14 plus 1 15, it will be 15. Then it can also reach to the end after 2 seconds. This is, I know, mathematical complex, but if you once understand it, this will become very simple. After 2 seconds it can also reach, its speed is 6 now, it can, so 1 2 3. So this ship can also reach to the end, but either we need to calculate it or in our answer, no, because we need only three ships to reach our end, which we have 1 2 and 3. Yes. No. So what is the number of ships we can reach is this ship, this two, and this one we can reach. This one ship can also reach to the end after 2 seconds with current position and velocity, but we don't need to calculate for it because we already have k number of ships. So why we increase our cost? We just when we just want to at least at most k ship. Okay, only k ships we want. Okay, so we will not calculate it because for it we need to ignore two more ships. So our answer will be 1 2 3 4 5 6 7. 2 plus 2 plus 2 6 plus 1 plus 1 7. So instead of 7, 5 is very good answer for only 3 ships. Okay, guys, we will not calculate our answer for extra number of shifts because we want to find out the minimum steps or the minimum ignoring cost. Okay, guys, now what we are given: current position, velocity, and total number of shifts. K number of shifts we want, B the barn position, the last position, and T is the time, in how many time. Okay, guys, so we take good, bad, and answer. Answer is my current answer at ith point. Bad is the number of ships that cannot reach to end with given current, and current is the time, current position, and velocity. So we have to ignore them. We need to ignore them. Okay, and we will answer good plus. Answer is good means these are the ships that can easily go to my position B after t unit of time. So I will run from reverse loop because for this the ship in front are these. Okay, so we need to calculate this ship for calculating answer for this particular. Okay, so I will calculate the distance after t, means is ship will be at this point after t units of time. It is ci current position into plus velocity into time. So if this position is greater than is equal to b, means yes, this ship can reach to position b, then I will increase my good count, and answer plus is equal to bad, means I need to ignore bad number of ships. Like for this I need to ignore this, I need to ignore this. Yes, I need to ignore this, I need to ignore this. For this as well I need to ignore this, I need to ignore this. But for this 4 I need to ignore only this. Okay, if I found a bad ship here, then it and I have found a good ship here, then it means all the bad ship till here should be added in my answer. This is a good ship, this is a bad ship, then it means all the bad ship from here at the end will be included in my answer, means I need to ignore them all. Okay, to reach at the end. Okay, else bad plus. And if at any position my good greater than is equal to k, I don't want to increase my answer because I already have k a number of ships, so I will return my answer. If I am come out of the loop, it means our good can never exceed or equal to k, means I am never be able to reach out to put k ships to my position b, so I will return -1. Okay, these are mathematical problem, you need to dry run it in on pen and paper. Okay, these are very weird mathematical problem. Okay, guys, so I hope you understand the problem, all the test case you pass out. If you have any doubt, first of all dry run this because this is a mathematical problem only. Okay, this is a simple mathematical problem, but with a weird statement. Okay, guys, so I hope you understand the problem. If you have any doubt, then just comment out, I will try my best to explain you. Please check out my channel for more these type of videos. I upload GFG problem of the day consistently. So please subscribe the channel, like the video, and thank you for watching this, guys. Stay tuned.